Okay, this is problem 11 from section 3.4. I thought I would give you guys another one that I thought was kind of difficult, and it involves another construction, a lot like if you just watched the 3.3 video, you have to draw in a line in order to understand this problem. Anyways, you got DF, which bisects angle CDE. So that means that these would be congruent. I need to say that in a proof. But I also got EF, which bisects angle CED. G is the midpoint of DE, which means that I will have to say that these two things are congruent. And DF is congruent to EF. Okay, so all the stuff that was given to me is drawn in there. And you could already see somebody in my book already drew this, but I need to draw in some lines. And if you got a floating point, something that's not really attached to anything, a lot of times what you're going to do with that is prove some triangles or draw a line to it so that you can create some triangles. So in this proof, I'm trying to prove that angle CDE is congruent to angle, CDE is congruent to angle CED. And this is going to be a pretty straightforward proof. The only trick was you needed to draw in those lines. So what you got in this particular problem is you need, basically I'm trying to prove these two triangles are congruent. That is, this is an F. That is FDG and FEG. If I can do that, then I can prove that angle FDG, this angle, is congruent to this angle, which would help me prove by the multiplication property that angle CDE is congruent to angle CED. So let's go with it. So I gotta figure some things out. So first thing I gotta say that was not given to me was the fact that DG, so I'm gonna say the given, was the fact that DG is congruent to GE. That was not in the given, so I need to say it. And it's a really simple reason. It's just because G is a midpoint, but you still need to say it. So if midpoint, then two congruent segments. All right. Now you have to say the reflexive property. Well, I created line FG. I still got to use it to prove the triangles are congruent. The reason these are congruent to itself is the reflexive property. So what I got is this congruent to this. Those sides are congruent because of the midpoints, and then FG is congruent to itself because of the reflexive property. Now, triangle DFG is congruent to triangle EFG. And note the way that you name it is very important because of side, side, side. Great, I'm not trying to prove the triangles only, I'm trying to prove that this big angle here, CDE, is congruent to this big angle here. Well, I'm just one small step away from being able to do that, and that step is to prove that angle FDG is congruent to angle FEG because of CP, CPC, those are corresponding parts. So once I see that these two angles are congruent, okay, this angle and this angle, since I know that the bigger angles that I'm trying to prove congruent are bisected, this is the multiplication property. So angle CDE, write that more clearly, is congruent to angle CED by the multiplication property. Well, I don't usually write multiplication. I say if small parts or small angles congruent, then like multiples are congruent. So that would be the perfect reason, multiplication. Yeah, that's not usually what we write, but if small angles congruent, then like multiples are going to be congruent. That's a 6-step proof to prove that those big angles are congruent.